confidence intervals for the mean. And sigma is known. Okay. Now we assume the sigma is known. That means the standard deviation is known. Definition. A point estimate is a single value, estimate for a population parameter point is a single value estimate for the parameters. So most unbiased point estimate population is unbiased point estimate of the population mean mu is what is the sample mean x bar. Okay, so the first things we're gonna define a point estimate. Okay, a point estimate, that means a single value. Okay, so for example, the very common point estimate, we use what? We use x bar. Okay, x bar. We know x bar is sample mean. Now let's take a look at an example. Example 1. A random sample of 40 students. Student athletes. Okay, is selected. And their numbers of hours spent on required athletic. You see it very clearly or not? It's a blurry? Oh, it's okay. Can you see it very clearly or not?
Yeah.
Okay, good. On a required athletic activities. for 1 week. Are recorded. Find a point estimate for the population mean. Mu. The mean number of hours spent on required athletic activities by all students athletes in the conference. Okay, now let's take a look the table. We have the table. For example, yes, 1925, 15, 21, 22, 20, and 2022. 22, 21, 21, 23, 22, 22, 16, 21, 18, 25, 23, 23, 21, 22, 24, 18, 19, 23, 20, 20, 24, 25, 17, 21. Okay, so I gave you guys a bunch of the numbers of hours spent on required athletic activity for 1 week. Okay, find the point estimate. Okay, so in order to calculate the point estimate, that means we need to calculate what? Based on definition, we need to calculate the sample mean, right? Because the point estimate for the population mean, we're gonna use the sample mean, X bar. I wish you guys still remember the formula of the X bar. That is what? Is the summation of all the values divided by the total number of the sample size, right? Sample size. And for this guy, what we're gonna do is just sum all these values, right? Sum all these values. Okay, and again, it will boil down to the value is 21.1. Okay, that's the result. You can do it by yourself. Okay, and here I just gave you the number. You can use your calculator. Try it by yourself. Okay. I think this is very straightforward. We already did such a thing before, right? We did a X bar, how to calculate X bar, just sum all these numbers and divide by the total number of the entries. and will give you the average. Now, here we adjust the point estimate. Now we're going to use the interval estimate. Okay, interval estimate definition. Let's take a look. An interval estimate is an interval or range of values used to estimate a population parameters. For example, here, let's take a look. The interval estimate is interval or the range. Okay, the range. For example, here, our last example is x bar is 21.1. That's a point, only one value. Now I want to construct an interval. Okay, construct an interval. So what are we going to do? Let's take a look. So x bar is 21.1. That's what we know. And now we construct a margin of error. Okay, margin of error. And this guy is 0.6. Okay, for example. So we can estimate the mu is in what? Is in this range. Okay, in this range. And we can calculate it. So calculate is at 21.1 minus 0.6 between this guy. Okay, if I give you the x bar and if I give you the margin of the error that is 0.6, and we can estimate the mu is between 21.1 minus 0.6, right? And the upper limit is 21.1 plus 0.6. Okay, upper bound is 21.1 plus 0.6. Okay, and we're gonna have what? The range is between 20.5 and 21.7. Okay, and the point is, you know, for this kind of things, it has a very strong application because when you do a survey, okay, you pick the sample from the population. There always some kind of margin of error, and then you can use the interval estimate. You got a mean value from the sample, and you got a margin of error, like 2%, 3%. And then you can estimate the mu by interval estimate, okay, like this way, okay, like this way. And of course, you guys probably noticed the present election poll, right? A lot of news, they do the poll. They always give you kind of margin of error because that's estimate from the sample. You never know what's the real numbers in the population. They always give you the sample value, right? So they should give you a margin of error. Okay. I don't know whether you guys already read the news or read the poll because tomorrow is the election day. Did you guys vote?
I'll be voting tomorrow.
You'll vote tomorrow. How about you? No. Okay. I feel sorry to hear that. I thought you guys already finished it before.
No, I finished it on Saturday, but I did mine tonight. I finished it on Saturday, but I was very exhausted because I wanted to. Since I had so much time left, I redid them all again, and it took 2 hours. And I was so tired. I just wanted to redo it. That's something I would do. That's normally what I do. I make sure
the test only allowed you to have 1 attempt.
Yeah, but I didn't press that. Yeah, if you don't submit it, you can go back to the question.
Oh, really?
So like, let's say, and then I started to check, and then one of the answers that asked for a Z score, when I redid it the second time, I was thinking, oh, why do I have that Z score? And then I did it like 3 times, and I kept thinking, maybe I didn't see well because sometimes, since those numbers are so small, you might make a mistake because you're trying to hurry up and you're nervous. So,
okay, I see.
And then I changed it, but I hope it was good.
Good luck. Good luck. Okay, so let's continue. The purpose of this test, I want you guys, one purpose of this test is want you guys to get familiar with the ProctorU. Okay, because the final will be proctored by the ProctorU team. And for this test, just 15%. Yeah, 15%. Yeah. Okay, anyway, try your best to get a good grade. Okay, so in order to do more things about the interval estimate, especially to calculate the margin of error. Okay, how to get this margin of error? Now we introduce a new parameter. We call it the level of confidence. Okay, so in order to calculate the margin of error, we need to introduce another parameter. Okay. Because in reality, we need calculator. Here, I just gave it to you, right? So now the level of confidence. See, is the probability that the interval estimate contains the population parameter assuming that the estimation process is repeated a large number of times. Okay, so now let's take a look the level of confidence, and we use the notation C to represent the level of confidence. And what does that mean? I'm gonna give you guys a picture. So if I have the normal distribution or standard normal distribution, okay? And how to find the level of confidence, or how to find the z-score corresponding to this level of confidence, okay? So let's take a look. The level of confidence is in the middle of the area. Okay, that's defined on the standard normal distribution. If I give you a standard normal distribution, the level of confidence means the area in the middle of these two z-score. Okay, that's the area in the middle of these two z-score. Okay, so now the question is how to find the z-score. Okay, how to find these two z-score. Okay, the strategy is here. The strategy is here. Some of you guys already complete the homework 5. You probably have kind of a sense how to find this guy. Because what? If I give you the area in the middle, okay, in the area in the middle, okay, we can see this part area is symmetric with respect to this middle line, right? Middle vertical line is symmetric. So that means this area and this area should be equivalent. Okay, should be equivalent. These two areas should be equivalent. Okay, how to calculate these two areas? Aha, should be 1 minus c, right? 1 minus c gonna be the area of these two, right? When subtract this area, gonna be the area of the left. Okay, these two areas. And divided by 2, gonna be this area. Okay, so divided by 2 and divided by 2. Did you get it? So we have total area is 1. When subtract the c, gonna get the left areas, these two parts. Okay, since we know these two areas are equal to each other. Okay, so we divide by 2, and we get these two areas. That's it. Okay, now that's the strategy. Okay, let's take a look at an example. I give you 90%. If I give you a C that is 90%, how to find the z-score? Z-score for this guy. Now let's take a look. So we know C equals 90%. Follow the way we learned. That is 0.9. Right? So the left area gonna be 1 minus C is 1 minus 0.9 equals 0.1. Right? And so the area to the left or the area to the right for this guy is 0.1 divided by 2. Or we can write that this way. 0.1 divided by 2. Right? Follow this formula. So 1 minus C, 1 minus C is 0.1 divided by 2. Divided by 2 gonna equals 0.05. Okay, since we know this guy is 0.05, the area to the left is 0.05. That means we can use the z table, right? We can use the z table because that is the area to the left. We're trying to find the area to the left from the z table. You're gonna find it 0.0. What? Let me check it. Negative. Oh, 0.05. Yeah, it's close to this number. -6. 0.05. Okay. So it's between these two numbers. You see it? So it's between this number and this number. So we're gonna do the average of these two. Okay. Because here is -1.6, corresponding this guy is negative, and write down is -1.65, and we do the average of these two. Okay, because in the table we only can find these two numbers. One is 0.0495, that corresponding to the z-score is -1.65. Another one is 0.0505, that corresponding to the z-score is -1.64. So you can tell the area to the left is in the middle, right? In the middle of these two numbers. That means we just do the average of these two numbers. That's the tricky part, okay? Be careful. So in the table, you couldn't find exactly the number 0.05, okay? 0.05. You can find these two closest number. One is 0.0495, okay? That corresponding to the z-score is -1.65. Another one is 0.0505. Okay, that is also close to 0.05. And that corresponding to the z-score is -1.64. Okay, you can tell 0.05 is exactly in the middle of these two numbers. So that means we could just do the average of these two numbers. We're gonna get the z-score. Okay, and this guy gonna give you that is negative. Okay, negative. And we can see from this definition, okay, so because here is negative ZC equals -1.645. So ZC is what? 1. Okay, so we get this z-score. And you can see this guy is -1.645. And this z-score is 1.645. Okay. Do you get it? Because here is a negative, here is a positive, right? So you let the negative ZC equals -1.645, and ZC equals 1.645. Okay, and I want to emphasize again, here's the area to the left. Okay, area to the left, then you can use the table directly. Okay, and also that's the area. It's a reverse process. You find the value in the middle of the table and get the z-score. It's a reverse process, okay? The second thing, I want you guys to try it. Please try this one for me. %. Okay, find these two for me. One is negative ZC, and another one is ZC. Okay, and follow the steps. Follow the steps. The first step, you subtract the C and then divide by 2. Right? After you find the area to the left, okay, the area to the left of this z-score, and then you can find use the table, right? Find the z-score. Okay, I'm gonna show you guys on board. So here, C equals 80%. 80% means 0.8, right? So 1 minus C should be 0.2, right? And 1 minus C divided by 2 gonna be 0.2 divided by 0.1. Okay, so that means what? That means the area to the left of this z-score should be 0.1, right? 0.1. Now we try to use the table, and the closest to the 0.1 gonna be negative 2.8. Okay, because the values closest to the 0.1 gonna be 0.1003. Okay, this number. Let me see it. Yeah, so closest to the 0.1 should be 0.1003. Okay, because here is an area, so you need to find the value in the middle of the table. Okay, so corresponding to the z-score gonna be negative 1.28. Okay, so z-score is negative 1.28. Okay, is that clear? Did you get this number? Okay, so negative 1.28. That means the area to the left corresponding to this z-score. Okay, is negative 1.28. That means ZC equals 1.28. Okay, is that clear? Mm-hmm. Very good, very good. Now I want you guys to try again. C equals 0.95, 95%. Yeah, try it again. Okay, let me write down the answer on board. You got it? 2.1? No, that's not right. Let me do it on board. So here is C equals 0.95, right? So 1 minus C gonna be 0.05, right? And 1 minus C gonna be 0.025. Okay, so you need to find this value from your table. And you can find this value is in the middle here. It's corresponding to a negative 1.9 come here. And it goes up is what? 0.06. So it's negative 1.96. Okay. 0.025 is here, right? Corresponding to the low is negative 1.9. And second digit is 0.06. So we find, okay, and then ZC is gonna be 1.96. That's it. Okay. Now let's move on. Let's move on. After we got this Z score, then everything gonna be very straightforward. Now I can define the margin of error. Error. Okay, error. Let's take a look. The definition. giving a level of confidence. C. The margin of error. E. Sometimes also called the maximum error of estimate or error tolerance. Is the greatest possible distance between the point estimate and the value of the parameter it is estimating. For a population, we have a lot of words. Mean value, mu, where sigma is known. The margin of error is what is here. E equals ZC sigma x bar and the ZC sigma divided by square root of n. The margin of error for you, we call that guy is a margin of error. Okay, and we define the notation as E, and this is the formula. And we specify for this case, sigma is already known. Okay, known. If sigma is unknown, what is gonna happen? We're gonna use another formula. Okay, so for this formula, only for sigma is known. Okay, sigma is known. Then we have the formula here. Okay, so here we have two important conditions when we use this formula. The first one, when these conditions are met, the sample is written. Okay. Second, at least one of the following is true. Is true. The population is normally distributed, or n is greater than 30. Okay. So the sample is written. That's very easy to confirm for this condition. And the second condition, the population is normally distributed. Okay. Or the sample size is greater than or equal to 30. Okay. If that population doesn't indicate that it's a normal distribution, that means you need to require the sample size is greater than or equal to 30. Okay. Now let's take a look. An example. Yeah, Z sub C, that is sigma over square root of n. N is sample size. No problem. If you couldn't see it, just let me know. Okay. Now let's take a look. An example. A researcher is collecting data about college athletic conference and student athletes. Student athlete, a random sample of 40 students athletes. Is selected. A 95% confidence level to find the margin of error. For the mean number of hours spent on required athletic cost. Or athletic activities. All students athletes in the conference. assume, okay, the population standard deviation is 2.3 hours. Okay, so let's take a look at this problem. So first of all, we can say here what? We can see that 95% of confidence level. Okay, that means what? That means C equals 0.95. Okay, that's the first information we got from this one. And the second one, we know the population standard deviation, that is 2.3 hours. That's very good. That means what? Sigma equals 2.3. All right, that's second information. And the third information, we select how many? 40 student athletes. Okay, 40. And it's very clearly, this condition is satisfied, right? This condition is satisfied. We randomly selected 40 students. So these two conditions will be satisfied. That means we can use the formula here. Okay, we can use the formula here because these two conditions are satisfied. One is randomly, another one is 40. Okay, and in order to use this formula to calculate the margin of error, we need the ZC. Okay, we already know the sigma. That's very good. That is 2.3. And we also know the sample size, that is 40. Right, 40. And the n we already know is 40. The only unknown is ZC. Okay, ZC. How to calculate ZC? We use the confidence level, right? Like we did before. So let's do it. For this guy, we C equals 0.95. That means 1 minus C is 0.05. 1 minus C divided by 2 is gonna be 0.025. Okay, and use the table. You're gonna find that guy is negative 1.96. Right? The area to the left of so the area to the left is 0.025. So negative ZC gonna find negative 1.96. Just like we did in the last example. I think we did it here, right? 95. Yeah, it's here, 0.95. And we got a 0.025. After you got a 0.025, you can use the table, find the z-score, right? Z-score. And for this z-score is negative 1.96. And the ZC is gonna be 1.96. Okay, that's it. Now you find the ZC, you find the sigma, you find the n. We're gonna plug in these three parameters to the formula here, right? We just plug in. ZC sigma divided by square root of n. ZC is 1.96, sigma is 2.3. Okay, now you can use the calculator to calculate this guy. It's about 0.7. Okay. And now, C confidence interval for a population mean is defined as like that. Let's take a look. So let's take a look at another definition like we did before. Probably you guys can try another one for me because I think you're probably not so familiar with this the arrow of the mountain. I just changed this number. Find 90% confidence level to find the margin of error. Okay, the same thing. Just change this number 95% to 90%. Okay, to 90%, and try to find the E for me. Okay, try it by yourself. I gave you this example just once you guys get familiar with this formula. Okay. ，please type your full name in the chat. I want to check your attendance. Thank you. %, confidence interval. Okay, confidence level. Did you get it? You still need more time?
Oh, yeah, I'm good. I was just going back and looking at my notes, making sure I did it right. But you can go, keep going.
How about you? Did you get the number? Okay, okay.
Yes, I got,
0.713. No, that's not right.
This, table is on my computer. It's harder to look at. And I can't see the numbers.
I feel sorry about that. Okay, so let's take a look. So here, C equals 90%, right? Equals 0.9. So 1 minus C divided by 2 is going to be what?
0.05.
Very good, 0.05. And you guys agree, from our last example, we know the ZC is negative 1.645. Okay, very good. So negative ZC gonna be you guys agree? We get this one. That's what we get. That's fantastic. Okay, now the left work, we're gonna use the formula, right? So E equals ZC sigma square root of n. ZC is 1.645. Sigma is 2.3 divided by square root of 40. And I got the number is 0.598. Did you get the same number?
I didn't get that far. I didn't realize we were doing that. I thought you had just went back to that part.
No, I want you guys to practice this formula.
Yeah, that formula, but with the 90%, correct?
90%, yes. So you got the ZC is 1.645. And we don't change the sigma and the square root of n, right? It should be 0.598. Okay, that's it. I think the key part should be ZC, how to find the ZC. After you got the ZC, just plug in the formula. That's it, okay? Now, let's continue the last part. C confidence interval for a population mean value is what? Is x bar minus e x bar plus e. Okay, so now if I give you the e is for example is 0.7 and the x bar is 21.1. Find the C confidence interval. Okay, now try this one. So now I gave you a definition. That's the whole definition. X bar minus e less than e mu less than x bar plus e. And that is C confidence interval. Okay, now I give you guys an example. If I give you E is 0.7, X bar is 21.1, find the C confidence interval. Okay, try it. What is interval for this guy?
don't know how to find the Z score.
Z score, which one?
I don't know what's wrong. It says the formula. It says X bar minus Z.
Or E?
Oh. Oh, okay. I was thrown off too. Like, what did I do? What am I missing here?
Okay, it's a very simple, just plug in.
Yeah, I was like, something's not right.
I just want to let you guys practice this formula.
Yeah.
It's an interval. How to find the interval. If I give you the E, if I give you the X bar, how to find the interval? Okay, I'm gonna write down the answer on board. So yeah, I think so. It's a very straightforward, right? Just plug in the numbers, X bar, E, X bar, and E, right? So here's a subtraction, 20.4, 21.8, right? So if you know the college algebra, if you already learned the college algebra, you can write that as this way, right? Interval format from 20.4 to 21.8, right? That's the interval format from college algebra, okay? And then we use the comma, right? We use the comma, and we use the parentheses in because here 20.4 is not included, so we use parentheses. Otherwise, if it's included, we're gonna use square bracket, okay? Square bracket. That's the point. Okay, I'm gonna wrap it up class here. Thank you for coming. Have a nice day.